In the last sets of videos, we talked about the array and array list data structures. Okay? Let's see if I can put all that on one line. Yeah, so in those videos we talked about the array and the array list data structures, and we talked about the pros and cons of each one. And the big pro of them that we actually didn't really mention was the notion of this constant lookup time. So what do I mean by that? I mean that if we know the index that we want to search for, I, then all we have to do is just do a at I or a.get I. And what's nice about this is that with the way arrays and array lists work, well, with arrays, we know that the elements are contiguous in memory. So we know the address of the starting value. All we have to do is just have a multiplicative offset to get any of the others. So by constant lookup time, it means that everything is side by side in memory. So when we're doing an index I, we're actually just looking somewhere else in relation to the first element. And the same thing with array lists, right? The underlying data structure of an array list is an array, so it works the same way. The big disadvantage, well, let's talk about array lists first. Another big advantage of an array list is the dynamic resizing. Okay, so that means that if we add an element to an array list and the underlying capacity is reached, we can just expand the array by doing the resize procedure that we talked about. The big downside of an array list was the fact that if we do insertions and removals, then they shift elements around. And the shifting is very slow. Okay? The example that we gave before was with if we're trying to remove or insert from the front of an array list. So if we do like while L is not empty, where L is an array list, and we do something like L remove at 0, then this is going to be very slow because with every removal we have to shift down all of the remaining elements, and that's very slow. However, there are certain data structures that make that easier. And in fact, there are plenty of other data structures that we're going to talk about in this new section. So in this section, we're going to begin to talk about something called the Java Collections Framework. Okay, and sometimes it's called the Java Collections API. It's the same thing. And in fact, we've actually already been talking about it with the array list class, okay, or the array list data structure. So the collections framework, the Java Collections Framework, is a collection of different data structures that allow us to do different things. And we're going to talk about three types of data structures. The first one is this notion of sequential based data structures. Okay? So we've already talked about arrays and array lists. So array list. So arrays are not part of the collections API. Those are just very primitive data structures that other things are built on top of. But there's also something called a linked list. Okay, and we'll talk about that in the next video. There are also these things called stacks and queues. And there's even something called a priority queue. Now, the reason why these are all called sequential-based data structures, or sometimes they might be called index-based data structures, is that every element lives at some index. Or rather, the location, the index of an element is significant. Okay? There are other data structures where that's not the case, and we'll talk about those now. The next type of data structure that we're going to talk about is something called a set-based data structure. So a set, if you remember from math, does not allow duplicates. So something like the set 4, 3 is the same thing as the set 4, 4, 4, 3, 3, 4. Okay? So just like in math, The set-based data structures don't consider duplicates. Okay, and then there's three types of things that behave like a set. There's something called a hash set. There's something called a linked hash set. And there's something called a tree set. And the unique property of all of these, or the property of all of these that's central to it, is that there are no duplicates. Okay? Each of them behaves slightly differently, and we'll talk about that once we begin to talk about these types of set-based data structures. Okay? The final data structure type that we're going to talk about is something called a dictionary-based data structure. Okay? So, what do I mean by this? Well, just like a dictionary in real life, a dictionary maps or associates words to their meaning. Okay? So, if you're familiar with how Python dictionaries work, it's kind of the same thing. So, the way dictionaries, or in Java, they're actually called maps. The way maps work is that they associate a key or keys to respective values. And we'll go through some examples when we talk about maps, but a simple example might be to map names of people to their age, or perhaps names to salaries, or perhaps names to lists of names. Like, for example, let's make this a little bit bigger so you can see it. Perhaps you might also have a list of, you might have a map where you have names that map to lists of names. So, for example, you could have a map of supervisors to, for example, the list of employees that they supervise. Okay? And my cat is right here. Hello. So, yeah. Maps are really cool and they're really interesting. And just like with sets, there are three types of maps. We have these things called, not scroll back over, but we have something called a hash map, and maybe you're going to see this coming. We have something called a linked hash map, and then there's something called a tree map. Okay? And the key thing, no pun intended, with maps is that they associate keys with values. That's the absolute big thing about them. So associate keys with values. Okay? So again, we're going to talk about all these different types of things, and we're going to start off by talking about sequential based data structures, and then we'll move through it all the way down to dictionary based.